Good morning, students. Today we see in exercise 8.3 the fifth one. I will see the question. If A vector, B vector, C vector are the three vectors such that the sum of A vector plus 2B vector plus C vector value is equal to 0 or 0 vector. And also the modulus A vector value is 3, modulus B vector is 4, modulus C vector is 7. Our question is find the angle between A vector and B vector. Here involving the three vectors, and also it satisfies some condition. Some modulus of A, B, C is given to find the angle between A vector and B vector. First we write the given data. First of all, given the sum of A vector, 2B vector, C vector is equal to 0 vector. Now to find the angle between A vector and B vector. So I keep A vector and B vector in one side and the remaining vector goes in other side. Suppose this plus C vector comes in RHS, it becomes minus C vector. It's a 0 vector or 0, so you don't consider. So the value is minus C vector because it is just 0. So plus C vector becomes that side minus C vector. We need the angle between these two vectors. We have some modulus of this vector is also there. So the next step is taking a square on both sides. A vector plus 2B vector the whole square is equal to minus C vector the whole square. Because to find the angle between these two vectors, so in this purpose the next working rule is squaring on both sides of this vector. So A vector plus 2B vector the whole square is equal to minus C vector the whole square. You know A plus B the whole square formula. The formula of A plus B the whole square is A square plus 2AB plus B square. But what is the formula of A vector plus B vector the whole square? A vector square plus B vector square plus 2 into A vector dot B vector. So this is the only difference between the ordinary numbers and the vectors. Now we see they are the vectors. So now using the formula of A vector plus 2B vector the whole square. So according to our formula we write it is A vector square, that is A square, plus I write B vector square. The value of B is here 2B vector. So we write 2B vector the whole square plus 2 into A vector dot B vector, but in place of B vector here 2B vector plus 2 of A vector dot 2B vector. So now we write A vector plus B vector the whole square. A vector square plus B vector square plus 2 into A vector dot B vector. You see in RHS minus and square is there. You know the minus is also become a square plus according to square. So we write minus C vector the whole square as C vector square also. So A vector square plus the value of 2B vector the whole square we write it is 2 2s are 4 into B vector square plus, you know by property in a dot product any one scalar is there, we will be taking outside the scalar. A scalar means a constant. Now you see one constant is there. So this constant is comes in outside 2. Already one 2 is there, 2 2s are 4. So 4 of A vector dot B vector is equal to C vector square. We already know one vector, suppose the square is there, we write it is A vector square or A square or modulus A vector square. So we write any manner. In our given sum, some modulus values is there. Modulus A, modulus B, modulus C. So I change all the square terms in modulus. Because square is there, so I write A vector square as modulus A vector square also. Plus 4. We write B vector square as modulus B vector square. Plus 4. We already know the formula of A vector dot B vector. The dot product of these two vector formula is First one vector modulus, second one vector modulus into cos theta. So the formula of A vector dot B vector is modulus A vector modulus B vector into cos theta. So modulus A vector modulus B vector into cos theta. RHS, we write C square as modulus C vector the whole square. So we can convert this A vector square as modulus A vector square possible only when the given vector has some square is okay. The next step, we substitute the given values. The value of modulus A, modulus B and modulus C, all values are given. So you see the value. The value of modulus A, the value of modulus A is given 3. So 3 square, already 4 is there. Next, the value of modulus B, the value of modulus B is 4. 4, but square is the 4 square plus 4. Okay, 4. Modulus A vector, the value of modulus A vector is 3. Modulus B vector, that value is 4 into cos theta is equal to modulus C vector the whole square. The value of modulus C vector is 7. 7 square. The value of 3 square is, the value of 3 square is 9 plus 4. The value of 4 square is 16 plus, we multiply the numbers. 4 3s are 12, 12 4s are 48. So 48 cos theta is equal to, the value of 7 square is 49. So 9 plus 4 16s are, 4 16s are is 64 plus 48 cos theta is equal to 49. 9 plus 64 is 73 plus 48 cos theta is equal to 49. We need an angle. Here what is the required angle here? Theta. So to find the value of theta only, because this theta is the angle between these two vector A and B. So the next step, we will take these plus 73 goes to RHS. The plus 73 goes to RHS, it become minus. So we write it is 48 cos theta is equal to, already 49 in RHS, minus 73. So 48 cos theta is equal to 49 minus 73. Okay, 73, 49. To subtract we get 73, 49. 13 minus 9 is 4. We take one borrow. So 6 minus 4 is 2. But big number is a minus, so it becomes minus 24. What about cos theta? Minus 24 by 48. The multiplication 48 becomes the side division. In 24th table, exactly 48 as twice. Cos theta is equal to minus 1 by 2. Suppose it is a plus 1 by 2. Okay. Then the cos value lies in the first quadrant. We already know in trigonometry the quadrant rule. According to our quadrant rule, the value of cos is a minus. You know the quadrant rule, the first quadrant, all ratios are positive. Second, sine and cosine are positive. Third, tan and cot are positive. Last, cos and secant are positive. But here cos, it has minus. So this angle does not lies in the first quadrant. You see this in second quadrant, cos is a negative. So the value of a theta is equal to 2 pi by 3. Using quadrant rule, I use the value of a theta is 2 pi by 3. I write in radian. 2 pi by 3 is nothing but is 120 degree. We already teach in trigonometry. Using a quadrant rule, we check. The value of cos 120 is a minus 1 by 2. 120 is the degree value and the radian value is 2 pi by 3. We use the value of theta is 2 pi by 3 is, then we get the value of cos 120 is a minus 1 by 2. So the angle between A vector and B vector is here. We write either 120 degree or 2 pi by 3. But we write all the sum in radian value. Therefore angle between A vector and B vector is 2 pi by 3. Suppose it is come 1 by 2. Cos theta is equal to 1 by 2. We know very well in 10th standard also, in which value of cos we get 1 by 2. In which value of cos we get 1 by 2 is a 60. 60 is nothing but pi by 3. But it come in plus 1 by 2. But it is a minus 1 by 2. So this theta angle lies in the second quadrant. The value of theta is 120 degree, or we get 2 pi by 3. So angle between A vector and B vector is 2 pi by 3. The next question is a 6th one. Show that the vectors, there will be 3 vectors, A vector, B vector and C vector, are mutually orthogonal. Another name of orthogonal is perpendicular. So now to prove these 3 vectors are mutually orthogonal, that means one is perpendicular to other. To prove A is perpendicular to B, B is perpendicular to C, and also the value of C vector is perpendicular to the A vector. In you know very well in vectors when they are perpendicular. Suppose whose dot product value is equal to 0, then we come to the conclusion they are perpendicular. We already know, I explained, when these 2 vectors are perpendicular. A vector is perpendicular to B vector. When it is possible, suppose whose dot product value is equal to 0, then these 2 vectors are perpendicular. If A vector is perpendicular to B vector, then A dot B is equal to 0. The reverse is also possible. If the dot product of these 2 vectors is equal to 0 means, we come to the conclusion these 2 vectors are perpendicular. Now A vector, B vector, C vector are given in sum 2 I cap plus 3 j cap plus 6 k cap. So, you know very well I cap, j cap, k cap are unit vectors. I remind the value of I cap dot I cap is always 1. I cap dot j cap value is 0. I dot I, the same unit vector dot product value is 1. The different unit vector value is equal to 0 because A dot B formula is, A vector dot B vector formula is modulus A vector modulus B vector cos theta. What is the angle between I vector and I vector, or I cap or I cap? 2 same cap, so whose angle is 0. So according to formula, modulus I cap into cos, okay, cos angle is 0. So that value is 1. And suppose I cap dot j cap, how it becomes 0? Using the same formula. I cap dot j cap formula is modulus I cap modulus j cap cos, what is the angle between these 2 cap? Is 90 degree, pi by 2, because I cap lies in x axis, j cap lies in y axis. So angle is pi by 2. So cos pi by 2 value is 0. You know already very well. So I explain I cap value is 1 and I cap dot j cap value is 0. Next, now to check the dot product of these vectors. Suppose all the dot product value is become 0, we come to the conclusion given the vectors are mutually orthogonal. The another name of orthogonal is perpendicular. First, we find the dot product of A and B. A vector dot B vector. A vector value is 2 I cap plus 3 j cap plus 6 k cap dot B vector. The value of B vector 6 I cap plus 2 j cap minus 3 k cap. Now we will be taking the dot product of these 2 vector. You know I dot I, j dot j and k dot k. They are become 1 and all the remainings are 0. So you multiply the coefficient of I cap first. 2 here 6. So 2 into 6 plus coefficient of j cap here 3 and here 2 plus coefficient of k cap 6 into minus 3. 2 6 are 12 plus 6 minus 18. 6 into minus 3 is minus 18. So 18 minus 18 is 0. So the dot product of these two vectors is equal to 0 means angle between these two vectors is 90 degrees. So A vector is perpendicular to B vector. Now to find the dot product of B and C. Now to find B vector dot C vector. The value of B vector 6 cap 2 cap minus 3 cap dot. The another vector is C vector. The value of C vector 3 cap minus 6 cap plus 2 cap. Now to find the dot product of these two vectors. We already explained. We multiply only the same I cap, j cap and k cap. Here coefficient of I cap 6. Here 3. 6 3s are 18. Next, we multiply the coefficient of j cap plus 2. Here minus 6. 2 into minus 6 is a minus 12. We multiply the coefficient of k cap minus 3. 2. Minus 3 into 2 minus 6. So it's 0. 18. So minus 12 minus 6 is minus 18. 18 minus 18 is 0. So B vector dot C vector is 0. So we say B vector is perpendicular to C vector. Now to prove A vector is perpendicular to B vector and B vector is perpendicular to C vector. We prove one more. That is, now to check C vector is also perpendicular to A vector. Now we write the value of C vector dot A vector. The value of C vector is 3 cap minus 6 cap plus 2 cap dot A vector 2 cap plus 3 cap plus 6 cap. Here also we do the same work. We multiply the same coefficient of I, j and k. 3, 2. 3 2s are 6. Minus 6, 3. Minus 6 into 3, minus 18. 2. Here 6. 2 6 are 12. So 18 minus 18. C vector dot A vector is equal to 0. That means the C vector is perpendicular to A vector. Now you see A vector is perpendicular to B vector. B vector is perpendicular to C vector. And also the C vector is perpendicular to A vector. Now we come to the conclusion. All the three vectors are mutually perpendicular. Mutually means A is perpendicular to B, B is perpendicular to C, C is perpendicular to again A. Therefore, the given vectors A vector, B vector and C vector are mutually is perpendicular or orthogonal. But in our question given it is orthogonal. Therefore, A vector, B vector, C vector are mutually orthogonal. The next question is, show that the vectors, you see there will be three vectors, 1, 2 and 3, form a right angled triangle. We already see in the question, but the given word is the position vector. But you see here the position vector is not given and also the name of the vector is not given. So the first step will be take the name of the vectors. So we will take the name of the vectors as usually we will take A vector, B vector and C vector. We will take the first vector as A vector. So the value of A vector minus I cap minus 2j cap minus 6k cap. And the second one is B vector. The value of B vector 2I cap minus j cap plus k cap. The third one is a C vector. That value is minus I cap plus 3j cap plus 5k cap. To prove these three vectors form a right angle triangle. You know very well every right angle triangle satisfies the Pythagoras theorem. Okay. What is Pythagoras theorem? The sum of the squares of the any two sides, it should be equal to the square of one side, that is hypotenuse. So now we will be taking the three vectors as the three sides, 1, 2 and 3. Suppose it satisfies the Pythagoras theorem, we come the given vectors form a right angle triangle. So in this manner, first I will take the modulus of each and every vector. You know the working rule how to take the modulus? First we will take the modulus of the first vector. Modulus A vector. Modulus of minus I cap minus 2j cap minus 6 cap. The working rule of modulus of a vector within a square root. The first step is coefficient of I cap. The coefficient of I cap minus 1, so minus 1 the whole square, plus coefficient of j cap. Coefficient of j cap minus 2 the whole square, plus coefficient of k cap is minus 6 the whole square. Square root of 1 minus 2 the whole square 4 minus 6 the whole square is 36. So modulus A vector value is equal to square root of 36 plus 4 is 40 plus 1 is 41. In Pythagoras theorem we need a sum of the squares of the sides. So the next step is taking a square. So modulus A vector value is equal to root 41. What about modulus A vector the whole square? So taking square on both sides, so root 41 become 41. Next, we will be take the modulus of the second vector. Modulus B vector. Modulus the value of B vector 2i cap minus j cap plus k cap. Same working rule. Square root of coefficient of I cap 2 the square, we put plus. Next we write the coefficient of j cap. Coefficient of j cap minus 1 the whole square, plus coefficient of k cap is 1 the whole square. Square root of 4 plus 1 plus 1. So modulus B vector value is equal to root 6. So the next step we need square. So modulus B vector the whole square value is equal to 6. Modulus B vector the whole square is equal to 6. Next we will take the modulus C vector. Modulus minus I cap plus 3j cap plus 5k cap. Same working rule. Square root of coefficient of I cap minus 1 the whole square. Coefficient of j cap 3 square. Coefficient of k cap 5 square. Square root of 1 plus 9 plus 25. We add. The final answer is 35. Root 10 plus 25 is 35. So modulus C vector the whole square value is equal to 35. Now you see any idea? Now we will be taking all the vector modulus and also taking a square. You see modulus A vector square 41. Modulus B vector square is 6 and modulus C vector square is 35. You see exactly the sum of 2 we get 1. 41, 35, 6. 35 plus 6 is 41. So now modulus B vector square plus modulus C vector square. We add these two because these two are small compared to modulus A vector square. 6 plus 35 is nothing but 41, but 41 is nothing but modulus A vector the whole square. Therefore modulus B vector square plus modulus C vector square, okay, is equal to 41, where 41 is exactly the value of modulus A vector square by Pythagoras theorem. Okay, you see exactly the sum of the squares of any two side vector is equal to square of one vector. So it satisfies the Pythagoras theorem. Therefore, by Pythagoras theorem, A vector, B vector, C vector form a right angled triangle. It forms a right angled triangle because this three vector satisfies the Pythagoras theorem. We will take the given vector names of A vector, B vector, C vector. So I write it is A vector, B vector, C vector. Or you write the given vectors form a right angled triangle also. So you either A vector, B vector, C vector, or the given vectors form a right angled triangle.